agenda. First, we're going to go over PC market dynamics and TBR's outlook for 2025. And then we will discuss AI PCs from a perspective of both heterogeneous computing and then implications on the next major PC refresh cycle. And we'll wrap up before Q&A discussing PC and AI PC differentiators in the market. As Haley introduced us both, my name is Ben Carbonneau. I'm a senior analyst, and I'll turn it over to Alex Maxfield, our research analyst on devices.
Great. Yeah, thanks, Ben. So as you mentioned, my name is Alek. So I'm focused on devices. So first here, just to kind of zoom out, and this isn't new news, but just giving some kind of context for the PC market dynamics that we're looking at. So sort of the story that we've been looking at over the past several quarters has been, we really saw that surge in PC purchases sort of onset by the pandemic, and everybody had those work from home, learn from home initiatives. So everybody needed a new PC. So that sort of had that huge surge. And then we had both some macroeconomic uncertainty sort of keeping IT departments from buying new devices on the commercial side. And then we had that kind of market saturation on the consumer side, which has created this sort of long-lasting slump over the past several quarters in the PC market. So the question has been recently, when is that slump going to kind of end, and when are we going to be expecting to see a rebound and a return to like material growth in the PC market? So the initial projections for 2024 with all of this in mind. So if we turn back the clock all the way back to sort of a little mid to late 2023, so expectations were initially that the next major PC refresh cycle, which didn't end up manifesting during 2023, was going to kick in during 2024, with that demand and revenue growth accelerating in the latter half of the year. However, as the year progressed, vendors started reporting encouraging but slower than expected improvements, especially in commercial PC demand. So this prediction had to go under some significant reevaluation, and the timeline for that refresh continued to be pushed out further, and overall revenue figures for 2024 were, those expectations were reduced. So that sort of big refresh cycle didn't truly kick in the way that was expected. So on to what we're sort of expecting for 2025. So vendors are predicting that the PC market will expand in the single digits overall year to year during 2025. So again, in terms of the timeline there, the demand recovery that will drive this growth is expected to be more heavily weighted towards the second half of the year. And commercial demand is going to be outpacing consumer throughout the period as organizations begin to replace fleets of devices. So this sort of flows into the next point, where we're looking at sort of trying to drill in to exactly what factors are going to be the driving force behind the refresh. So first of all, there's the simple fact that there exists, because of that huge surge in purchases, there's this large aging install base of PCs that need to be replaced. The question is just when and in what timing. Another aspect of this refresh cycle is the impending end of life for Windows 10, which is currently set for October 2025. So that's going to be a pretty significant driver. And then lastly, and this sort of flows into our next topic, one of the final drivers of that refresh cycle that OEMs are citing is the sort of ongoing release of more advanced AI PCs, as well as the increasing use cases for those AI PCs.
Awesome. Thanks, Alek. And then just to kind of build off my introduction. So again, my name is Ben Carbonneau. And here at TBR, I'm a senior analyst on hardware. So I look at both PCs as well as IT infrastructure. But I'm also pretty focused on semiconductors. And I think that's a pretty big piece of the picture with respect to Alek's last point around AI PC. And I want to kind of touch on that since I know it's a big subject for the industry. So the first question really is, what is an AI PC? And the definition of AI PC varies across different PC OEMs and silicon vendors, but there's consensus that an AI PC is a personal computer that includes a dedicated AI engine, otherwise known as a neural processing unit or NPU. While CPUs and GPUs are capable, in some cases better suited for AI workloads, NPU is a relatively new addition to PC system on chips, or SoCs. And while Apple's homegrown M series chips have featured NPUs since their debut in 2020, today we'll be focusing primarily on Windows-based machines and the silicon that powers those. So really first, to set the stage for this discussion of AI PCs, I think it's important to go over a brief history of PC processors. The first PCs brought to market leveraged only a central processing unit, or a CPU, which was designed for general purpose tasks and sequential processing, which made CPUs very flexible and well suited for workloads requiring a relatively limited number of calculations and high levels of accuracy and precision. However, the sequential processing nature of CPUs throttled their performance on workloads requiring a greater number of lower precision calculations, such as graphics rendering. Adding additional CPU cores to a processor enabled parallel computing on CPUs. However, while multi-core CPUs are common today, the introduction of multiple cores drove complexities in software development, increased power consumption, and greater heat generation compared to single-core CPUs, which led to workload and scaling limitations. To address these shortcomings, the GPU, or graphics processing unit, was born, prioritizing parallel processing speed over accuracy and precision by employing a higher number of smaller and less powerful cores optimized for parallel computing. As such, certain workloads requiring parallel computing were offloaded from the CPU to the GPU, which enabled greater system efficiency. Over time, major GPU companies, including NVIDIA and ATI, who was later acquired by AMD, continued to develop increasingly powerful GPUs, and developers started thinking more about leveraging GPUs for parallel processing workloads beyond graphics rendering, which gave way to the era of general purpose computing on GPUs, which had been a vision of NVIDIA's CEO, Jensen Huang, since the company first introduced the GPU in 1999. The introduction of NVIDIA CUDA in 2007 and OpenCL 2 years later is what laid the framework for developers to code applications for both the GPU and the CPU, with an emphasis on portability, which led the GPUs to become the more generalized computing component that they are today. Foundationally, the general purpose GPU, or GPGPU, gave way to machine learning and other artificial intelligence workloads. So why do we need NPUs if we already have GPUs? And this is something that has really been a focus of my research recently. So like modern general process GPUs, or GPGPUs, NPUs are optimized for parallel computing. However, in contrast to GPGPUs, NPUs are specifically designed and dedicated to supporting matrix multiplication and addition, which is at the heart of all neural networks, including those that enable machine learning. GPGPUs, such as NVIDIA's lineup of GeForce RTX GPUs, which are found in workstations and gaming PCs, include what the company calls tensor cores, which are specifically designed for general matrix multiplication operations, but they also include cores for ray tracing that enable advanced graphics. However, because all the cores found on the NPU are optimized for matrix multiplication and addition, the NPU is best suited for repetitive and less complex AI tasks when compared to the GPU, allowing these types of operations to be offloaded from the GPU to the NPU, again, leading to greater system efficiency. And with this greater system efficiency, we get extended battery life, and that's really one of the main reasons we have seen in the past NPUs been integrated into smartphone and other edge device SoCs for years. Onto AI applications and use cases. What are AI PCs used for, and what is their value proposition? Today, the NPU found on AI PC SoCs, including those designed by Qualcomm, Intel, and AMD, typically are leveraged for the same workloads that they are leveraged for in smartphones, including background blurring and video calls, audio suppression, and object detection, and photo and video editing. However, perhaps the most compelling AI PC application today is Microsoft Recall. Recall essentially takes snapshots of a user's screen each time the content changes, storing these snapshots locally and organizing snapshots into a timeline that can be searched using natural language prompts. Recall is capable of searching for text, images, documents, and applications, and users can quickly jump to the content seen in the snapshot using Recall's relaunch feature. However, while Microsoft originally planned to roll out Recall alongside the launch of its first Copilot Plus PCs in June 2024, Recall's debut was delayed by Microsoft, with the company announcing that the application would be made available to certain Windows insiders just weeks later. Albeit following this announcement, Microsoft further delayed Recall's pre-release to October before ultimately delaying the release for a fourth time. These delays were directly associated with Microsoft's work to overhaul recall security in an attempt to address scrutiny tied to cybersecurity experts' concerns around user privacy and data security. Over the past several months, Microsoft has made recall now a fully opt-in experience, allowing users to completely uninstall the application from their Copilot Plus PCs. Additionally, Microsoft announced recall will be turned off by default and will feature settings that allow users to turn recall off when they visit certain sites, such as those that present personal finance or medical information. Further, Microsoft has invested in strengthening the encryption of users' data. And finally, on November 22nd, 2024, Microsoft began to gradually allow Windows insiders who were enrolled in the development channel of the program access to the application, granted that they were using Qualcomm-powered Copilot PCs. Although less than 1 month later, Microsoft expanded the availability of its recall feature to Windows insiders who are running AMD and Intel-based Copilot PCs as well. While these developments highlight the myriad user privacy and data concerns that surround AI, they also underscore one of the key value propositions behind on-device AI. In contrast to other AI applications that are cloud native or leverage hybrid architectures, recall stores users' snapshots locally on the user's device and does not require internet connection to function. However, like with most things, there are trade-offs, and on-device AI is no different. For AI workloads to run natively on the device must have enough compute power and be supplied with enough energy to support these operations. So on to potential impacts on the PC refresh cycle. Heterogeneous computing architectures leveraging CPUs, GPUs, and NPUs, often integrated into single SoCs with shared memory, help to address some of these challenges. And while NPUs do yield some AI workload efficiencies, TBR believes PC OEMs and other ecosystem players must continue investing in the further development of AI PC applications if they want AI PCs to truly be a meaningful driver of the next major PC refresh cycle. However, despite the nascency of the AI PC and the lack of killer applications, TBR believes AI PCs and NPUs will proliferate the market, with most, if not all, flagship Windows PC releases going forward featuring AI PC silicon from the likes of AMD, Intel, and Qualcomm, a cycle that mimics the diffusion of the NPU and smartphone SoCs, including those based on both Android and iOS platforms. Nonetheless, in the context of the 3 PC refresh cycle drivers that Alek mentioned earlier, TBR sees the advent of the AI PC being the least influential, overshadowed by the aging PC install base, as well as the end of Windows 10 support, which is slated for October 2025. Our last topic today will be how vendors will differentiate themselves in 2025 and in the AI PC market. So first, I'll let Alex take PC OEMs here.
Yeah, so one of the major ways that PC OEMs are trying to differentiate their devices is what we're calling AI-enabled feature sets. So this may be something like what Lenovo is doing with their Aura Edition PCs, which is a specific lineup that they've developed in collaboration with Intel. So with these devices, they have these different modes. So they have a mode dedicated to improving your PC's security through AI, or there's also one focused on improving collaboration, where there's special features for enhancing video calls and things like that. Second here, we have services focused on driving AI PC adoption. So this will be things like Lenovo's AI PC Fast Start or Dell's Accelerator services for Copilot Plus PCs, where the focus is sort of on the advisory side. They're focused on helping users evaluate their needs and roll out AI PC deployments, and then also training users on how to take advantage of the productivity and performance improvements offered by these AI PCs. Finally, here we have proprietary AI agents from the PC OEMs. So probably the most notable of which here is Lenovo's AI Now. So AI Now leverages a local large language model built based on Meta's Llama 3 and allows users to interact in real time with their device's personal knowledge base rather than having to rely on cloud computing. So this sort of ties into that focus on data privacy. So this allows for enhanced data privacy and also allows for generative AI features without having to rely on internet connectivity.
Great. So second, how vendors will differentiate, I really think it comes down to the other ecosystem players as well. So while certain PC OEMs are working to accelerate the adoption of AI PCs by providing toolkits and supporting AI application development and management, as is the case with Dell's recently announced Pro AI Studio offering, which is organized within the company's AI Factory portfolio, TBR believes other ecosystem players such as Microsoft and the major PC silicon vendors will continue to play a critical role in accelerating AI PC adoption. For example, in October 2023, Intel launched its AI PC acceleration program to attract both independent hardware vendors and independent software vendors to its platform by connecting them with a wide range of resources, including AI toolkits and joint marketing opportunities. And similarly, in 2023, AMD launched Ryzen AI software consisting of tools and runtime libraries to optimize and enable applications to run on the NPU. It's also worth noting that both Microsoft and Qualcomm offer a range of developer resources, such as software development kits and comprehensive documentation to better enable the creation of AI applications that leverage the NPU. As such, TBR sees much of the differentiation in the AI PC market being driven by these silicon vendors' developments. However, as we've already seen, the three major PC OEMs are all intently focused on bringing silicon variety to their customers and integrating AI PC SoCs from the three major Windows PC silicon vendors into their respective portfolios. However, similar to what Lenovo has done in collaboration with Intel on its Aura Edition lineup of AI PCs, as Alek mentioned, TBR expects to see major PC OEMs partnering more deeply with silicon vendors to create new and unique user experiences. And lastly, before we open it up to Q&A, I want to kind of leave off with a final thought here. While we often hear trillions of operations per second or TOPS used as a measurement of a processor's AI performance, I think it's important to understand that while 50 NPU TOPS may seem impressive, NVIDIA's flagship GeForce RTX GPU, so again, that same GPU that we're seeing in AI-enabled workstations as well as gaming PCs, delivers 1,321 TOPS of AI performance. And additionally, CPU cores that are on some of these SoCs from Intel, Qualcomm, and AMD add to the silicon platform's overall AI TOPS. So really, TBR's takeaway here is that the value proposition of AI PC heterogeneous computing model, incorporating the NPU alongside the CPU and GPU, is really primarily centered around overall system efficiency more than it is on enabling net new workloads. I think that's a really important distinction. I think maybe the larger customer base thinks that the NPU and the way that it's been marketed is enabling net new functions. And while Copilot is limited to being supported on these Copilot Plus PCs with NPUs capable of 40 or more TOPS, these workloads can be run on GPUs just as easily. Again, just kind of going back to those 1,321 TOPS that we're seeing from an NVIDIA GPU, there's much more AI performance that you can get out of the GPU than the NPU. However, the NPU, again, since it's all the cores on the NPU are designed for matrix multiplication and addition, the NPU is going to run certain workloads more efficiently and consume less battery. So that's really where TBR sees kind of more of that overall system efficiency rather than the enabling of net new workloads. And with that, we can open it up to a question and answers in the last few minutes that we have here. So I have a couple questions, and I'll read them out. And then Alek, we can kind of tag team these. The first is, are GPU-enabled workstations considered AI PCs? I think this is a good question. In my head, the term AI PC is kind of something, I think of it more as a marketing term, and it really has to do more with the inclusion of the NPU on those PC SoCs. However, when thinking about the AI PC through a lens of PCs that enable AI workloads, a lot of these workloads and what NVIDIA is doing with GeForce RTX, some of those larger workloads like fine-tuning large language models, those are definitely workloads that are better suited for GPU-enabled workstations. So I think that kind of just ties back to the definition of AI PC not being consistent and solid across silicon vendors and PC OEMs. I want to say that recently on one of the NVIDIA earnings calls that I was sitting on, Jensen said something like all of our GeForce RTX enabled workstations are AI PCs. I think potentially, the rest of the industry might argue that they're not because they might not feature a PC SoC that has an integrated NPU. But again, these GPU-enabled workstations are really, much more capable for some of the more intense AI workloads. Another question we have is thoughts on Qualcomm PC share for 2025 and then 2026. So I think that's a great question and something that we think a lot about. These Qualcomm chips that were introduced originally when Microsoft announced Copilot Plus PCs are ARM-based versus the x86-based chips that we're seeing from AMD and Intel. Qualcomm doesn't have the license to produce x86. Only Intel and AMD they're the primary x86 manufacturers. So Qualcomm really leads Windows on ARM, which is an initiative that Microsoft has been investing a lot of money into developing. However, I think Qualcomm's PC share will be throttled by just backwards compatibility of applications. A lot of these, legacy applications that are run, especially in the commercial side of the market, are x86 based rather than ARM based. And while Microsoft's putting tools out there to, port and emulate some of these x86 applications on ARM based chips, the performance, obviously, of a x86 native program that's being emulated on an ARM chip is going to be less than the performance of the x86 application being run natively on an x86 chip. And I think with the introduction of these new chips from AMD and Intel, such as I want to say Intel Lunar Lake and AMD Ryzen AI 300, I think we'll see a lot more kind of adoption of those PCs, especially now that they can also be considered Copilot Plus PCs with Microsoft's inclusion there. I really think that maybe this first wave of adoption of Copilot Plus PCs was limited to those Qualcomm-based devices just because of Qualcomm's NPU capabilities, that Hexagon NPU that they put on their chip. But with these new chips from Intel and especially that AMD Ryzen AI 300, that chip actually has an NPU that's even more powerful, circling back to those higher tops performance coming from the NPU on the AMD chip. And now that those are, Copilot Plus PCs, I really see that being adopted more than those Qualcomm PCs. So I don't really see Qualcomm's PC share shifting all that materially. I do think one thing that's important to note is that in smartphones, like all smartphones run ARM-based chips rather than x86. And that's primarily for power efficiency cases. But I think this kind of runs into what we see in the data center where AMD EPYC and Intel Xeon, they really dominate server CPUs for enterprise OEMs. And we haven't really seen that many ARM CPUs going into data centers, except for those that are customly made for hyperscalers. So I think, again, that has to do with the applications being based on those types of architectures. Moving on to the next question. Any signs that RISC-V PCs might start being a thing, especially in China, given US export restrictions? So this isn't something that I've heard too much about. Definitely something I think we'll be following here. Maybe not super closely, but definitely will be on our mind, especially as we see with the new administration, kind of see what they're going to do with these export restrictions on China. I also know the Biden administration signed in that AI diffusion rule recently. So I want to kind of wait to see what the implications are there. I haven't seen any signs personally recently that I've read about, but definitely something that we'll be tracking. And I think something that could potentially evolve in 2025 and 2026, depending on, if those AI diffusion rules are overturned, and then what the next administration does with export restrictions to China and other countries. So we still have time for a couple more questions here. Another question I have is, NVIDIA recently announced its GB10 desktop. Will that compete with Copilot Plus PCs? So that's a good question. This was like a really big topic of CES. I think of the GB10 desktop more as a server than I do as a PC. It's going to run Linux, a Linux-based operating system. I believe it's the DGX operating system that NVIDIA has. So I don't see it directly competing with Copilot Plus PCs or really competing with them at all. Again, it's really, designed more for those model builders and much more compute intense tasks than would be done on a Copilot Plus PC. And I think the last question I have, at least for right now, is another one just on AMD and Intel Copilot Plus PCs versus those based on Qualcomm. Yeah, I definitely see AMD and Intel-based Copilot Plus PCs being more widely adopted than those based on the Qualcomm chips. Again, having to do with x86 and ARM. However, I do see Microsoft continuing to invest more heavily in building out ARM native applications. And I think this has a lot to do with kind of competing and benchmarking against Apple computers. So I want to say in my head, I know Qualcomm and Microsoft have worked closely on developing ARM chips. I think it was their SQ series for Microsoft Surfaces. That's been going on for years. Recently, that program ended. And now, Microsoft Surface is just using those Qualcomm Snapdragon Elite chips. I see those, lending extended battery life to Windows-based PCs, but really, I think it's the application and that whole ecosystem, the developer ecosystem, that needs to catch up with respect to ARM native. I do think that, potentially that is why maybe Microsoft wasn't including those AMD and Intel-based machines first when they first announced Copilot Plus PCs, potentially to benchmark. They were benchmarking better with the Qualcomm-based Copilot Plus PCs against Macs. Recently, I even know I was watching the CNBC. And I think they had Microsoft CEO on there. He was just talking about Copilot Plus PCs, especially those with Qualcomm chips, and how that they, were more powerful for AI workloads than some of those Mac computers. But he was also really talking a lot about that extended battery life. And again, that's what TBR really sees as the driving value proposition behind these AI PCs with the NPU. And again, I think one last point here, if there's no more questions, it really ties into the type of AI workloads. So I think there's three types of AI workloads, really. There's on-demand workloads, there's sustained workloads, and there's pervasive workloads. On-demand workload is more something where you're making a query and you need an instant response with very low latency. That might be something that's best done, depending on the model size. If it's a very small model, that's something that the CPU can handle. For larger models, definitely more complex operations, I'm thinking that's more of a GPU kind of use case. Whereas the sustained and pervasive AI workloads, those can be kind of thought of more as, I think when I think of AI agents, I think of them more as a pervasive workload, in the sense that they're always running in the background for contextualization. And because that is always running in the background, and especially on a mobile device, such as, a laptop PC or notebook PC, power efficiency is really the key performance indicator there. So that's where I think the NPU will deliver the most value. But again, I don't really see net new workloads really being enabled by the NPU. I think we'll hear about more applications that leverage the NPU because of all these developer tools that have been put out there. But really, would the GPU-enabled workstation be capable of running that workload? Certainly, if it was coded for it, certainly they're just generally more powerful at this time.